This is lesson 3 in our course in troubleshooting. This is also our third video dealing with the assembly of a digital multimeter kit. Let's go to page 2 of this file. This time we're taking a look at the assembly associated with section C, where we'll be building our AC voltage and current circuitry. Let's go to page 17 of this manual, which will actually be page 16 of your paper copy. In the kit again you'll find a plastic bag with parts in it. There'll be a collection of resistors and a potentiometer, just like last time, some capacitors, diode and a semiconductor, and some hardware. The diode that we're going to use in this section is a little different than the one we used previously. This one has a glass body. Be able to look inside and see what's inside a diode. And then there'll be a black band painted around one end of it. Again, there's a polarity associated with some components, and with the diode, this barred side means the negative sign. So again, have you put the components in the board where the legends indicate the part number or a picture of the schematic symbol. Here's showing the diodes with the negative side pointing up here. Again, be very careful how you're putting these into the board. This section also uses an integrated circuit. So instead of soldering that integrated circuit into the board, we're going to put a socket in first, and then we're going to insert the integrated circuit in the socket. So if we do burn out the IC or we need to change it, it's a pretty easy thing to do. As I mentioned last time, just like our diodes have a polarity, the integrated circuit also has, in a sense, a polarity, in that we need to orient the integrated circuit so that the pins are in the right order. The little groove or notch here on one end is indicative where pin 1 is. So the pins are actually counted in a counterclockwise direction. There's 7 on this side and 7 on this side. So once you complete this part of the assembly, we're then going to do a series of tests for calibration for AC voltage and for AC current. Our AEE makerspace has quite a bit of sophisticated instruments in the room for us to use. And so we're going to take advantage of those in doing these calibration steps and allow us a little bit more accuracy. Once you finish this calibration, I would like your lab supervisor to sign off somewhere around here that you've completed this section successfully. Now when you look at the description of this YouTube video, you'll find a link to this lab procedure similar to what we had last time. This time we're looking again at section C of the assembly process. We'll be using a new piece of equipment. This is the Philips PM5193. It's a programmable synthesizer and function generator. We're going to use this to create an AC voltage. We'll also need some alligator clips like last time and a resistor. You can find this resistor and others in the parts cabinets that are in one corner of the lab. There are several different types of stations in the AEE makerspace, and so I'd like you to find a station that looks something like this. We're going to be doing the assembly on page 17 of your assembly manual. I'd like you to hook up this equipment in the following way. The Philips generator has a special type of a connector for its output. It's really meant for high frequency connections, although we're going to be doing a audio frequency signal. It's called a BNC connector. It's a cable that has an interconnect that fits into here, and you're going to insert it and then turn it and lock it. The other end we've actually clipped off and put 2 banana leads on. Hook up the red one to the high and the black to the low, and then take another wire over to the voltage input of our digital multimeter that we're building, and then the low side to the common. On the side here is a schematic drawing of these 3 instruments hooked together. Show a voltage source as a circle with a plus and minus inside of it. And the digital multimeter has a positive and negative terminal, and so does the digital multimeter that we're building. When you measure AC signals, we're actually measuring the magnitude of the sine wave, and so it's always positive. So these polarities really have much effect on what we're going to see on the meter. When we do hand calculations, there is a direction that we need to do. This will eventually lead to a phase angle. The procedure here for running this equipment is a little bit more involved than last time, so I'll have you read through this and again follow the instructions carefully. If you've not built anything before, again I would prefer you have the lab supervisor kind of walk you through this. And again, if you have experience, you just kind of follow through yourself. We're going to run through a variety of test voltages, make the adjustments that are described in the assembly manual, and then turn off the instrument when we're finished. The next section deals with AC current testing. I'm going to have you connect these instruments up just like before with the power turned off, and then we'll flip the power back on, and then we'll do a variety of measurements. We're going to use the BNC cable with banana connectors at the other end. And this time we're going to hook up the red wire into the current input of the Agilent digital multimeter and take the output of that and bring it over to the input to our digital multimeter, and then come out of the output of that through a resistor back to the function generator. The schematic symbol would be our function generator here, hooked up to the plus and minus of the ammeter, and then likewise the plus and minus of our digital multimeter that we're building back through a resistor. The meters have ideally a very low resistance, and so the current that we're going to see flowing is really the voltage here across this load. One thing that's not shown here is that this generator actually has a 50 ohm resistor stuck in series with it over here. When we do calculations of current, it's going to be this voltage divided by the 50 ohms here plus the 100 ohms here. It doesn't really make a difference what we calculate. We're actually going to match these two meters to have the same reading. There won't be anything to adjust in this section, just simply going to be verifying that the adjustments we did in the last case are also producing the correct results. If they don't, that means there's some type of a wiring error, and we need to find where that is. Example of the calculation. I'm going to set this thing to 5 volts RMS. That's the units that we use AC voltage measurements in. And divide that by the total resistance in the loop here, which is 150 ohms. And so we expect to see on the meter something like 33 milliamps. But the function generator is not that super accurate, and so you're going to be somewhere in the neighborhood of this number. And all I want to do is make sure that both meters read the same value. I'm going to have you then calculate other ranges of current for the meter so that you can also verify that the scales are working. There's another section in the instruction manual that talks about a high current test for AC, checking that the shunt wire is working correctly. But we don't have to really do this because we've already calibrated the shunt wire. This is also pretty dangerous to work with, so we're going to postpone that for right now. A few more steps to finish after this last step of current testing, so please read through that. Have your lab instructors sign off on the work being done correctly. And this is lesson 3 in our Troubleshooting 101 course.